Python Flask web servers can be left in a configuration state called debug mode, where developers can access variables or see code running in the application, and even access an interactive console where they can run commands with the Python interpreter. Now, if this is left on for an application in production, it can be very bad because an adversary or threat actor could compromise that application. Thankfully, this is sort of mitigated in that you can actually enable a PIN or identifying number that will only allow access to the console if someone knows it, and this is normally just shown to the developer within the console when they spin up their application, but under some misconfigurations, this PIN could actually be determined and then taken advantage of if there are other vulnerabilities present. I want to show this to you in a Capture the Flag challenge that I made some time ago for NomCon 2021, so let's get started. But wait, before we dive in, please allow me to include a message from today's sponsor. There are so many vulnerabilities out there, like prototype pollution, SQL injection, remote code execution, and more. They're fun to play with in CTF challenges, pen testing, and ethical hacking, but they're not so fun when they're in your own applications. And that is where Snyk comes in. Snyk automatically scans your code, dependencies, containers, and config files, finding and fixing vulnerabilities in real time. Here's how easy it is with Snyk. You can sign up for free with my link below, import your repositories, and there. Snyk just finds your vulnerabilities. And it's not just looking for old deprecated libraries. Snyk literally found a serious command injection vulnerability in a project of mine. So all I have to do is fix it with a single click. Snyk will open up fixing pull requests so you can just merge them into your repository and move on. And it does this all from your existing tools, IDEs, the command line, repos, pipelines, Docker Hub, and so many more. And you can see for yourself. Check it out and find out if there are any vulnerabilities affecting your projects. It's all totally free, and you can sign up using my link, snyk.co/John Hammond. Huge thanks to Snyk for sponsoring this video. Okay, so I am in my Kali Linux virtual machine, and I'm going to fire up a terminal here. And bear in mind, I'm going to be showcasing a challenge that I had previously put together. So I am going to be just showing this on my local host, right? I am going to be compromising a Docker container running the application that I have on my own machine. So bear in mind, when you see references to localhost, just play pretend it is sort of a, hey, no, okay, this is the application I'm going against, despite it being quote unquote my own machine. So you'll notice that I'm running my Docker container. I'm exposing ports 5000, mapping it to 5000 inside the container, and running my worker bee image. This will start up my Flask server here, and you'll note, oh, this is a development server. Do not use this in production deployment. And it's running on port 5000, bounded to all addresses, and note the debugger is active, and just as I mentioned, the developer, or the person spinning up this application, might have access to the PIN. It's going to be printed right there on their screen. So now that the application is spun up, let me just put that away. I'm going to put that in another terminal and move away from it. And what I'm going to do is I'm going to fire up my web browser. I can navigate to this application, which is running on localhost port 5000, remember? Zooming in here, this is the website. This is the interface that we are presented with for worker bee. Looks like your best worker, and task me to collect the honey, give me a destination, and I'll bring back the goods to the hive. Looks like there's a sidebar over here for recent tasks, and then a placeholder input for where we might be able to go. Give me a destination. Okay, so seemingly a web challenge right off bat, right? If this was a capture the flag thing that we're going to be up against, you could start with the small stuff, right? We could kind of, hey, go visit this thing at robots.txt or take a look for sitemap. Okay, that's not present. We could take a look at the source code with a right click and view page source or hit Control U on your keyboard. This is all going to be HTML, so nothing all too interesting here. Looks like there's no easy low-hanging fruit for us. But clicking around, I do see a link down here. Copyright over to worker bee, and clicking on this looks like over in the bottom left, if you can see on my screen, link to /worker bee. Ooh. Okay, so going here, I see a Jinja 2 exceptions template not found, and this is actually an error message. This is straight Python error as part of what Flask web server might offer for us. And you'll notice if we actually take a look through different file names that are presented here, just as I mentioned, okay, it's listing out the entire traceback or the error that would have happened during runtime. If you take note of the file path here, we are going to be using Python 3.6. So that's actually pretty worthwhile information, something we should keep in mind, the version of Flask that we are up against. Looks like we don't actually have the template workerbee.html to render out for us, but if we scroll down and try to take a look through here, well, we could see some of the code that it might be referencing, And at least at this point, we know that we are, in fact, up against Flask and WorkZug, or how this is built by deploying that in a Flask web server. And we know we're working with Python 3.6, so that is worthwhile info. Let's see if we can move back and go to this interface here. Give me a destination and I'll bring back the goods to the hive. Okay, looks like it's trying to go to, as an example, https ctf.nomcon.com. And remember, this is a challenge that I had put together for the 2021 Capture the Flag NomCon game. So this actually does not exist anymore. That URL is actually down, so that's not going to return anything for us. Let me try a different URL. How about my own website? Here's johnhammond.llc. Ooh, okay, cool. Success. We collected the honey and returned it like so, and this is the HTML or the actual source code to my website. So it must have just gone out and reached that page. I see that it's created over here in the recent tasks. Good to know, but how could we take advantage of this? How could we play with this? Can I go to example.com? Oh, no, it says we require a secure HTTPS destination. Well, I could try and just spin up like my own server. Like you could use Updog. Updog would be nice and handy because Updog will actually allow you to work with SSL. Like if I just go ahead and actually go to this address. Before I do that, let me make a temporary directory. And now we can Updog that. Like naturally that'll give me HTTP. And if I go navigate to this address, okay, there's nothing present here. But I wouldn't be able to access this since we know, okay, this requires a secure HTTPS destination. We can use Updog with TAC SSL though, I believe. Yeah, so it'll spin up HTTPS nice and easy with the self-signed cert. So if I go back to my web browser over here, Google Chrome, my web browser will let me know, hey, this is a self-signed certificate, but you can cruise through it if you want. I'm curious what worker bee will do against that. Oh. Didn't want to verify the certificate. Okay, so that didn't work for us. Annoying. What else could we do? Could we try to do some like a command injection stuff? Like if we need HTTPS present, could we like, here, let's go to that. We at least know that it tried to, well, what could I verify? What could I like try to test to see if it actually went to it or not, despite other stuff being in the way? Like, can I go to example.com and HTTPS John Hammond LLC? I think I broke it. Not seeing anything come back. I should actually open up developer tools. I'll hit F12 on my keyboard. If I refresh this page, so trying to go to this with the destination being slapped in as a get parameter and variable. This does tell me, oh, WorkZerg 1.0.1, at least as the server headers in Python 3.69. So that validates what we saw earlier, and we can at least see that in the headers. But I want to be able to do more stuff. I want to be able to... Does example.com serve on HTTPS? I've always known that... Oh, wow. I've always known that as strictly HTTP. But I guess it can also roll there. Or it might just redirect. I don't know. But it tracked that down. What else could I reach for here? I could use the semicolon. Does that break it every time? I think it does. Let me keep F12 open and try and buzz here. Okay, yeah. That just never comes back to me. We could use like an ampersand, maybe. Treat it as another variable. Question is, where could we get this? I want to be able to see how this is doing it, so I want to be able to like cause an error. I don't know if it will for me. Oh, no. It's going to repeatedly give me an actual error, like nicely within the application. What if I just add more crap? Still doesn't work for me. Can I just throw in like a random schema? Oh, that needs HTTPS. Where does it need HTTPS? Can I just do like FTP blah, 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 HTTPS : //? Still not doing anything. What if... Here's a thought. What if I use like HTTP? Oh, it actually returned. But so that went through it and I didn't get the HTTPS error. So what if I went to http://example.com with like a comment sort of thing, or like the anchor tag that you might normally see in applications? If you click on like some part of the page, the octothorpe or hashtag or pound symbol, whatever you want to call it, does that work? Ooh, that actually does. Could I do that with like other schemas? That's like going to take its time. It's probably not going to be able to reach that. But that might let me know that it just needs HTTPS somewhere in the inputs. Like it doesn't need to be at the very, very start. Oh yeah. Okay, so it's trying to go for that original FTP request. What if I try to read local files? Etc. password, and then I'll use that same like comment octothorpe kind of thing. And I need HTTPS, right, to verify and validate that. Ooh. Okay. So this is etc. password, which is normally like a world readable file, right? And we see our user is apparently worker B, bin sh. There's nothing else all that interesting here. But that gives us arbitrary file read. So we could read whatever we want. Okay. It's not like I could just do like cross-site scripting or anything in here. I don't know if I'd be able to just go ahead and find a flag, right? Is there going to be... Well, let's look at where I am. Let's use the proc file system and try to find my current working directory. And that tells me, oh, it's a directory. Oh, that's actually interesting. It gives me that. So could I try and read a flag from the current directory? No. What is part of my command line? What are we running? Okay, Python 3 worker b main.py. And this has a space here, but it isn't going to be rendered out all that easily. If I go to Python 3, you'll notice there's this weird little space, because I think it represents it in like some null bytes or something when it's actually spat back out to you. So, okay. Can I go back? Well, we know from clicking on our worker bee link that debug mode is on, right? That's the only reason that we get all this dump. So, with that said, we should be able to just go straight to /console, which is like always active, as a accessible console when debug mode is on, right? But it requires a PIN. The console is locked and need to be unlocked by entering the PIN. If we didn't have this PIN in the way, we could just like use the interactive console in the back there and just literally import OS, run whatever commands we wanted to do, and then we would own this thing. But this PIN is getting in the way. So how can we track this down, considering now we know that we have arbitrary file read? Is it in like the environment variables? We could check proc self environ. No. And this has more garbage in it, so let me scroll back down to that. User home, log name, path, lang. Okay, so nothing interesting in there. Oh, it has a work server FD file descriptor and run main true, but it doesn't have the pin code for us though. Okay, so we have arbitrary file read, and we know that we need to get it into this console. Is there anything that we can do? Let's do like a work zug pin exploit or a vulnerability. Oh, Hacktrix has some stuff here for us. Hacktrix is a phenomenal resource. If debug mode is active, you could just try to access console, yep, as we know, and then just gain remote code execution with importing the OS module. In some occasions, the console endpoint is going to be protected by a pin. Here, you can find how to generate this pin. Okay, here's an option here from Dehi. So if you have a console locked message, Console is locked and needs to be unlocked by entering a pin. You can find it at /console, as we did. You can reverse the algorithm that generates this console pin. If you inspect the debug code present on, like in their source code, yeah, we can just straight up go to how this application is put together on GitHub. Like, you could straight up see the code. Pin time, hash pin, get machine ID. Oh, okay, so this is going to need some, like, extra shenanigans. How long is this file? 500 lines? Well, let me see what the rest of this blog post showcases, but this is good to know as the source code to reference if we ever want to go back to it and kind of parse through this a little bit more. It says, okay, in this file, the relevant method outlining the steps to generate the console pin are get pin and cookie name. So it retrieves it from the environment, like an environment variable. If it's explicitly disabled, or if the pin is explicitly provided, otherwise you do all these things. Huh. You have a couple properties here. Authenticated code. Let me go see what this explains. The variables that are needed to exploit the console pin are in this list of probably public bits, being username, mod name, get attributes. So we know the username is the user who started this application. Mod name is flask.app, just like a static string. Get adder app name, get adder, lots of dunder functions, is just Flask, okay, seemingly as a string. Get adder is the absolute path of an app.py in the Flask directory. UUID get node is the MAC address of the current computer as a string. String of the decimal expression of the MAC address. Okay. Get machine ID. So we need the MAC address. We know the user. We kind of need to also know an absolute path of app.py in the Flask directory. And we need the machine ID. To find the server MAC address, you need to know which network interface is being used to serve the app, like ENS3, so you can leak procnet ARP. So still using the proc file system here. See if we can leak that out. I have too many forward slashes. So procnet ARP, I'm assuming will let us see whatever ARP table sort of thing. Ooh, yeah. And I have IP address, hardware type flags, hardware address mask. Is my interface not there? Oh, I'm just zoomed in way too much. Trying to make sure you guys can see. Okay, here's a device. So I know that I'm operating off of interface ETH0. And what else do we have here? Once you have the device ID, the interface, you can then leak the MAC address at sysclassnet device ID address. Okay. So let's try all that. Once again, I gave myself too many forward slashes. And remember, we need to include HTTPS at the end here, and we can sort of comment that out, so to speak, right? So device ID we know is ETH0 from our previous leak. Let's spit that out there. Cool. So now I have the MAC address for this running target. And it needs that from hex. Convert from hex to decimal by running it in Python. Okay, Updog. I don't really need you anymore, Updog. Not gonna lie. So let me just slap this into Python, and then I'm gonna remove all of these colons here, because this as hex, like denoted with the 0x, should give me it in decimal, which it does. Super cool. Once all the variables are prepared, run the exploit script to generate workzug console pin. Wait a second. What about machine ID? Is that just going to be in etc. machine ID? Well, okay. I mean, we can just kind of use this. This is code that came from the original source code, right? Basically, that's whatever algorithm generates the pin. So let's copy all this. And let's subble genpin.py. slap all this in. And there are some things we know we need to change. The username we know was worker_b. Flask.app is constant. Flask is constant. And getAttr. Oh, this will work because we just know it is. We basically saw that this exact file path from when we went to worker_b, didn't we? Yeah. Just leaking a single error or getting a single error will tell me, look, flask.app is in Python 3.6. So that's why that version was important for us. So let's grab that and switch that to 3.6. We know our device ID interface number here, and that's in decimal. Remember, we just leaked that. So let's slap that in there, and we need machine ID. So this needs to still be changed. So can I go leak that? Let me do a file machine ID https:// excuse me. That's just not there. There just isn't a machine ID. What are you talking about? Did I skip something? Oh. Get machine ID. Read the value and it's set machine ID or in proxys kernel random booti. Okay. Read the value and return directly if there is. What does that mean? Let's try that one. / https:// no such file directory. What? Booti? Boot? Where else is that? Is there an easier way for me to track that down? I need to know the machine ID, but I apparently just don't have one. What does Hacktricks tell me? They basically have this same setup here. What do they do about the machine ID though? Okay, they define this a little bit more. Boot I. It needs to be boot ID. Are you kidding me? Okay, it's just missing the. Okay, it's just missing that last letter there. I mean, you know what? Can't fault them. Let me do that again. Boot ID. Makes sense. Okay, now we have this. Let's slap that in there. So ultimately, this does whatever reverse engineering algorithm to get the pin, and then we'll print it out, right? This is all that this does. We filled in all the ingredients that we need for this recipe, I think. So let's just try it. Go back to my terminal. We do a Python 3 gen pin. Ooh. 272.866.006. Heck yeah. So let's go try that in /console and paste in our pin. Nice. Okay, that's awesome. That's awesome. That's super duper cool. So now we're in the interactive console and we can do whatever the heck we want. Validate that we can run Python code? Yeah. All right, so let's import OS, right? Basically get a reverse shell, shall we? How about that? We can just make this super duper easy. Let's just go to revshells.com and let's grab the, we'll generate a reverse shell for Python. How about that? Python, scrolling down, holy crap. Python. This is all exporting stuff. This is straight up syntax. I guess I can use this. Or we just don't need those strings in there. We do need to set our own IP addresses. So what is my current IP? Docker, right? So I guess I'm 172.17, this thing. So let's spin that up on quad 9. Slap that in. Change the port here. And now I can grab this portion. And let's see if we can get a shell from running this. Fingers crossed. Paste all this in. Yeah. Oh, that's super duper cool. Okay. I am worker bee. And I have a shell. I'm just going to open up bash. And there we are. We are in and compromising and beating up this machine. So we have the actual source code of this application here if we wanted to take a look. Oh, app route worker bee. Okay, this would be the actual link, and that's where it breaks. But it says, oh, to do, explain the worker bee request process, include docs on URL lib request URL open for the destination. Because all of this just above is actually the source code to be able to retrieve the pages. Oh, and that's what they're checking. They're checking literally if not HTTPS in destination. So it's not like a prefix. You don't specify the schema as the absolute start of the string. It just has to be somewhere in there, which is why we're able to bypass that. So that's kind of slick. How come we can use that like Octothorpe though, or like the hashtag or the pound symbol to be able to do whatever else we wanted to? How do we retrieve this? We use URL lib request URL open. And I guess that just has some weird idiosyncrasy, like to allow you to do that. Whatever. Can I clear the screen? No. Term equals X term. Clear. Okay, whatever. So I don't have a flag in here though. Do I need a privesc? Can I privesc? Just. Oh. Okay, so that's kind of dumb. Sudo tac L. So I can run whatever commands I want with sudo. Super user do, right? To be able to come root. Looks like I have the ability to do whatever I want without a password. So I can just sudo bash. And now I'm root. Who am I? Oh? Don't have arrow keys because I didn't stabilize my shell. I am root. Okay, so let's move into root's home directory. And there is our flag. There it is. Okay, cool. So let's grab that. And that's it. Boom. Challenge complete. Taking advantage of Flask applications that leave debug mode on with local file inclusion or the ability to read sensitive information files to generate the pin. Super duper cool. That is it. We could submit that for points. So the actual application here, actually I can move back to the source code here because again, this is all kind of written locally. Okay, so when I originally put this thing together, this is a CTF challenge that I had made again for NomCon. So I created this sudoers file specifically to be included in the Docker instance that would give worker bee all those permissions. So the privesc was dumb, but I figured, hey, the player had already done enough work. The solve script that I had put together for this actually will automate the process of leaking all these out and actually retrieving specific Docker IDs with cgroups. Really, not everything is necessary in this, and it's gross regular expressions, but it would carve it out and then go determine all this because this could very well differ between each deployed instance. Whenever we create and spin up our games, we have different available instances for every single player. But that would end up going ahead and actually running the commands within the developer console to, hey, spit out the flag. Now, the application itself, cheesy thing, me testing, getting Flask code running. The app, can I move into it? Here's main.py, yeah. So this vulnerable instance here, URL lib request URL open, actually is kind of a callback because I had found this with an old CTF write-up. Plaid CTF was it called Meme Factory? I don't think it was. I think the challenge that CTF write-up, maybe they reference. So I recreated this and tried to anyway with a challenge renderer, Ghost in the Shell code. There are some other references. Oh, rekey, fail overflow, URL open, maybe view meme. I wanted to recreate this. Here it is, Plaid CTF 2014. Is URL open present in here? It is. Okay, so let me showcase this super duper quick. Old CTF, right? But some of the write-ups for it had a meme site. We grabbed the source code for the application, and then you were able to review. What they end up doing is requesting files and actually or requesting websites, right? Hence a website that would be able to render out and give you memes. But it has arbitrary file disclosure because you control the URL, which is what is passed into URL-lib open. And that is exactly what I wanted to showcase and recreate in here. When they do this exact same technique, file : / absolute path, and then commenting out, sort of kind of having this octothorpe in here. The schema in the end here are just having whatever anchor tag fake the notion that I have the necessary allow list syntax in here, but I still just want to be retrieving a local file. For some reason, URL-lib just ignores or just treats it at whatever anchor tag, so it's not necessary. And then they do some pretty cool stuff, actually exploiting this in Django. So sequel to this challenge, after I wrote worker bee, I created a second challenge called Bumblebee that does a similar thing with arbitrary write rather than arbitrary read. It's sort of a sister challenge, and hopefully I'll make another one called Queen Bee or something cool, but I'm trying to think of a novel way to put that together. So that's just the small gimmick here, and URL-lib is in that reference. I don't know if I have Meme Factory to be able to show you. Do I have my Meme Factory? I do. Let me see if I can build this. Oh, this is using like old Python 2. Probably showcasing, I think, this exact same thing, but I never publicly showcased this challenge. It was just for training with some good friends. Anyway, while that is spinning up, I can actually go ahead and show you Bumblebee. So now both of those Docker instances are building, but I'm curious, what did WorkZerg in the reference here on Hacktricks actually call out with one of these CTF write-ups? Is this one of mine? No, okay, so it's a separate one, the Prophet. I don't know when this challenge would have been released. But similar sort of thing, right? At least in the case of brute forcing or determining what the debugger pin might be for a Flask web application. There are a couple of worker bee write-ups. If you look up for NomCon 2021, you can find them on CTF Time, and Westar, I think, put together a really great one. So if you ever want to check out any of the interest on that, this was a hard challenge and actually only had 19 solves during the game. And NomCon 2021 had like, what, 6,000 players? Something? 8,000? 2022, we had 8,000. I think we were around the 650 or 6,500 options. So in 2021 anyway. Super cool to see the write-ups, and I'm very pleased that some folks were carving through it. Not too hard when you look at it in hindsight, right? But what does Bumblebee look like? Just for a nice little tease, something that we could do in the next video. Looks like that's running on port 8,000. So let me fire that up. I think. Go to localhost 8,000. This is a Django here. Ooh, oh, yeah. So Django, again, debug mode is on, but we would need to add, hey, some specific allowed host set for it. Can I go to like 127? How about that? No? What about my own IP address? 172 whatever the heck. Whatever. We'll tease it as Bumblebee could be something we'll showcase in another video, but you could probably find write-ups for it just online. Meme Factory is still going. Again, that's a really old one. It's not all that important. I think the challenge is dead anyway because it would literally pull down from websites to retrieve meme images. But one last thing that I would like to showcase here for us, because our good friends for the sponsor of this video, and this is just some love, Sneak actually wanted to, I would like to see what could Sneak find. So we could try to actually use Sneak to see what can it find within this application. Is there anything that it might find and track down as a weakness, as a vulnerability, as a flaw that could be exploited in this application that, whatever developer may have put out there? I'm curious what it will track down. Ooh, okay. So it found run with debug true. So clearly, hey, debug mode is still on. That's a bad thing. Run with debug true. Insecure hash, that's actually in the exploit.python script. That's not the application, but cool. At the very, very least, it found with the run with debug true, which is the crutch of this issue. It wasn't aware of what you could do with the URL lib, URL open, but then I think that's a pretty niche thing and not so much a vulnerability, quote unquote, but just the nature of the functionality of that library. So that's pretty slick. At the very least, it tracked down, look, man, you should not be running with debug true. Alongside that, we could try to actually test against the Docker container. I think it's container test and then the image name, so worker B in my case. And let's see if it will carve through this. Oh, that's looking at dependencies to see, okay, is there any other weaknesses probably in all that it's built on? And I think that's straight out of Ubuntu, and then just installing all the things that it needs. But let's see if there's any other things specific to it. Oh, yeah. Okay, found 46 issues. Base image is out of date. That's right, because I am using Ubuntu 18.04, not the latest. And there are some severity vulnerabilities, or medium severity vulnerabilities in AppArmor, BinUtils, GCC. Okay, cool. So this is figuring out all the stack and everything that's built on top of, still kind of roughing it up. So while there were issues and flaws in the code itself for the application, there could still be some things to fix and clean up as part of the entire container and structure. So that's super duper cool. And I appreciate Sneak showcasing all that right away. At least ironing out, dude, what's a low severity vuln? What's a medium severity vuln? What should I actually be concerned with? And nice to get that breakdown. So huge thanks to Sneak for helping me know what is both secure and insecure in my vulnerable applications that I put out online. And that's it. That was some of the dangers of leaving the Python Flask web server in debug mode when there are other vulnerabilities like a local file inclusion or arbitrary file read in place. So I hope you enjoyed. If you did, please do all those YouTube algorithm stuff. Like the video, leave a comment, subscribe, hit the bell. There are a significant amount of you, like literally I think 50%, I might have been like 55 or 60% that aren't subscribed. So if you watch these videos, please subscribe. Seriously, that helps grow the channel, it helps get in front of more people, and it helps support this cool community thing that we got going on here. Anyway, again, huge thanks to Sneak for sponsoring this video, and I'll see you in the next one. Love ya. Take care.